let's look at how we would answer this type of question. This says to fill in the blank for the following equation. 3 times some number equals 21. And this is done with whole numbers, so probably you should feel comfortable enough to kind of see what goes in there. But for a moment, let's say we don't know what goes in there. How would we go about finding it? Well, asking what number times 3 is equal to 21 is exactly asking, we can find that with division. Of course, this would be 7, because 3 times 7 is 21. But, like I said, let's say we don't know that. If we wanted to find this number, what we'd do is we'd do 21 divided by 3 to get that 7. So this question of asking what number times 3 equals 21 is exactly 21 divided by 3. So if we wanted to solve something like this, if we have what number times 25 equals 275, well, n, the number we're looking for, would end up being 275 divided by 25. So again, this is the same question as what happened up here. It's saying what number times 25 equals 275. Well, 275 divided by 25 would give us that number. And then we could just ask the calculator to do that for us. 275 divided by 25 gives us 11. So n in this case would have to be 11. M, in this case, what number times 6 gives us 96? Capital M would be 96 divided by 6, for the same reason. So we pull out our calculator. 96 divided by 6 gives us 16. So M would be 16. Now, don't just take my word on it. We can always check these. And to check to see if something like this is true, what we would do is we just say, okay, well, let's try plugging it back in. Well, 25 times some number equals 275. Well, 275. I'm checking to see if this is true, so I'm going to do a question mark over this equals. I'm checking to see if this is a true statement. So I'll just plug it into the calculator. What is 25 times 11? 25 times 11 gives me 275. You can see that one comes out correctly. And the other one, this one here, I have 6 times 16. Times 16 gives me 96. So I can check this by saying that 6 times 16 equals 96. And I just do a check mark after I verify that. So again, I'm taking this 6, that's the 6 right here, times the m, which I said had a value of 16, that's what I said right here, equals 96. So I'm just copying down that original equation with a question mark there since I'm verifying it. I just evaluate both sides. Well, there's not much to evaluate on the right-hand side, but evaluate the left-hand side and see that it comes out as a true statement. Alright, so let's make this a little bit trickier. Let's say, okay, what number times 100 is equal to 550? If you're trying to do this by, kind of guessing the numbers and checking, this would not be the easiest approach, because you'll notice if I do 550 divided by 100, 550 divided by 100, it doesn't come out as an integer. It doesn't come out as a whole number. We get 5.5. But of course we could check this. 100 times 5.5 question mark equals 550. So I could ask my calculator to do 100 times 5.5, that is, and we get 550. That one comes out correctly. Okay, so that one you might have been able to get, 5.5 times 100, but when you get to something a little bit more complicated, like 12 times y equals 99, I don't know about you, but I don't immediately see what number we'd multiply by 12 to get 99. So this is, this is where this process comes in handy. We say 99 divided by 12. I could ask my calculator what that is. 99 divided by 12 gives me 8.25. And just because it didn't come out as a whole number doesn't inherently mean that we made a mistake. If we want to check to see if we made a mistake, we just try plugging it back in and see if this is a true statement. If 12 times 8.25 is actually 99. 12 times 8.25, you can see that comes out as 99. Alright, so it actually doesn't matter which side of the equation our variable is on. So on all of these, we had the variable on the left-hand side of the equation. We can do the same thing if the variable is on the right-hand side of the equation, but you have to realize that we're now saying 8 times p equals 88. So if it helps, you could actually rephrase this so that the variable is on the left-hand side of the equation, if that helps you setting it up. But in any case, I'm saying what number times 8 equals 88. So P is equal to 88 divided by 8, which is 11. Now, you really want to be careful with something like this, because oftentimes I can almost guess that some of you looked at this and you said, okay, A is 2. But let me check that. Let's check what happens if A is 2. This would then say 15 is equal to 30 times 2. 15 equals 60, which is clearly not true. So let's do the same process I've been doing. I'm saying what number times 30 is equal to 15. So you'll notice that on all of these it was always the bigger number divided by the smaller number. That does not always have to be true. It's saying what number times 30 equals 15. Well, the one on the other side of the equation was always on the top part of the fraction, and the one that I'm multiplying by is always on the bottom part of the fraction. You can see up here I took 550 divided by 100. It was 550 on the top and 100 on the bottom. Here I'm taking multiplying by 12, that's the number on the bottom, and it's equal to 99, the number on the top. So it's multiplied by 30, that's the number on the bottom, and it equals 15, that's the number on the top. Well, I can reduce this fraction down to 1/2. So you can see actually if I was to check A equals 1/2 in this, I would get that 15 question mark equals 30 times 1/2. And 30 times 1/2, if you want to call it 0.5, that would work as well. 30 times 0.5, or 30 times parentheses 1/2. I'm just putting it in parentheses there to make sure I'm dealing with 1/2 and there's no funny business with the order of operations. You can see I get 15 for both of those. So this is a true statement. All right. Yeah, okay, so we've already been doing that.